Hey guys, it's Miss Helen here. So we are going to be starting our new unit, woohoo, astronomy, coming up for our next lesson. So I wanted to give you kind of some background information and really just kind of go over some of the easier concepts in this video instead of waiting to do it in person because it's kind of easy and we might as well spend our time together going over harder stuff. So this lesson is on cyclical patterns in space. So we're going to go over what a cyclical pattern is and some basics about the Earth's movement in our solar system. So first up, a cyclical pattern is basically just a pattern that occurs over and over and over and over again. So it says that a cyclical means occurring in cycles or recurrent. So I always like to think of it as like a bicycle wheel. Like bicycle, if you were to map one point on that bicycle wheel as it's traveling down the road, it would be going over and over and over and over and around and around and around and around. Same thing happens with these cyclical patterns. And in space, we're looking at them because of how these objects in space, the Earth, the moon, and the sun, are kind of moving around one another. So we're looking at cyclical patterns in space, meaning patterns that occur over and over and over again due to celestial movement. And then over here, it says that this means that certain space phenomena occurs in repeated patterns. I just want to make note that the word phenomena does not mean phenomenal. In fact, it just means an event that occurs. So really in science, anything that occurs is technically a phenomena. If your ice is melting, it's a phenomena. Ooh, doesn't sound so phenomenal, but it is technically an event that occurs based on science. It's a loss or a transfer of energy. So anytime we see phenomena, don't necessarily think that it means phenomenal, even though we are learning about space and pretty much everything in space is phenomenal. Phenomena just means an event that occurs. All right, so first up, we're going to start with Earth's revolution around the sun. Basically, all of the planets in our solar system travel around the sun, and it travels in an elliptical orbit. Now, heads up, elliptical is a descriptive word, an adjective, that describes the shape of the Earth's orbit. And basically, elliptical just means oval shaped. Okay, if you think of like an elliptical trainer machine, again, if you were to like track the movement of your foot or your arm, it would be going in an oval shape as you use the machine. So Earth and all of the other planets travel in an elliptical orbit around the sun. Basically, they do this because of the gravitational pull of the sun, but we'll be going over that later on in detail. Now, for Earth to make one complete revolution around the sun, it takes 365.24 days. Okay, and that's what a year is. Now, typically, you have heard that 1 year is 365 days. However, this 0.24 is a little interesting. So we'll talk about this more in person, but start thinking of what that could mean. If it's not exactly 365, it's actually 365 and 24 hundredths of a day. How could that potentially mess with our calendars and our kind of tracking system of time? All right, now looking again at Earth's revolution around the sun, we have this elliptical shape, but you'll notice that it is pretty circular. It's not like a long, skinny oval. So the ellipse is barely elliptical. It is very close to being a circle. Now, granted, the sun is not quite in the center. It is a little off-center. And that means, because the sun is off-center, that the Earth will be closer to the sun at different points throughout the year. So as it travels along, and this is kind of interesting too, the perihelion, when it's the closest, it's about 147 million kilometers away, happens on January 3rd. So we are closest to the sun in distance, 147 million kilometers, on January 3rd. Let that sink in for a moment. Weird, huh? And the furthest away we are, as it travels along, is July 4th. That's pretty weird too. So typically, people seem to think that the seasons are caused by, when we're closest to the sun, it's summer, and when we're furthest from the sun, it's winter. But looking at these dates, would you agree with that statement? I don't know about that. We'll talk more about this when we meet over our live stream. All right, the other thing that we need to talk about, or the other motion that Earth has, is Earth's rotation. So we have Earth's revolution around the sun. Earth's rotation is different. That is just rotating, kind of spinning around its axis. So if you were to think of the Earth as like a top, and you were to put kind of a line straight through the Earth, straight through that spinning GIF of the Earth, that would be called its axis. Okay, so the Earth spins around its axis just as a top spins around its spindle. Think of it as a dreidel as well. Okay, the spinning movement is Earth's rotation. So again, different from revolution. Revolution is around the sun. Rotation is just spinning in place. Earth rotates once around its axis about every 24 hours. So Earth's rotation makes a day. Okay, Earth's revolution makes a year. Rotation makes a day. Now, there is another, just like there was for revolution, there is another kind of misconception that happens. And sometimes on Earth, if you were to track the sun, you would see that it kind of rises in the east and sets in the west. Okay, it kind of makes that nice arc over through the sky. But in reality, in terms of our solar system, the sun isn't really moving. It's kind of in the center of everything. So when we see the sun rising and setting in the sky, it's not that the sun is moving, it's that the Earth is moving. So from nearly all points on Earth, the sun appears to move across the sky from east to west each day. Of course, the sun is not moving from the east to west at all. It's just Earth rotating. The moon and stars also seem to rise in the east and set in the west as well, and that's just because of Earth's rotation. So anything that we see in the sky that appears to be moving, I mean, obviously it has to be in the solar system. A plane is actually moving. But any planet, the moon, the sun, those objects are kind of staying still relative to us in terms of a day. It's the Earth that is rotating over that day that causes things to appear to move. So just a fun fact there for us too. All right, this is where we will stop. When we get together for our live stream, we will go over the rest of these slides and do a quick recap on this. But be sure that you are doing your exit pass as well. And then I will see you for our live stream. Adios, friends.